Connor, we're dedicating this lesson to you. We miss you, buddy. We hope you're doing okay. We thought we'd do some coordinate geometry for you. So, there you go. All right. We want to do two things today that are review, and then one thing is new. The thing that is new is not complicated. It'll look foreign right away, but it's not that big of a deal. Something that you do know about is the distance formula. Distance is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay? Distance formula. Given 2 points, you should be able to find the distance between them. This came up in geometry and it came up in algebra. A for the day. Who knows where the distance formula comes from? It's not something we just made up. Anybody see where it comes from? Pythagorean theorem. Thank you. So I'll draw this out. Tyler said it. But if you would have a coordinate, say x sub 2 and y sub 2, and another coordinate, say x sub 1, y sub 1, then if we want to find that distance, we can simply just make a triangle. And this distance is x sub 2 minus x sub 1. This side is y sub 2 minus y sub 1. And that distance would be c, otherwise we call it d. And note if you take a squared plus b squared, you get c squared. Just square root both sides and you get d. So it is the Pythagorean theorem right there in front of you. So nothing different. That is a theme that we're going to take care with us the rest of the way here. But distance formula, there we go. Now, when we get to the midpoint formula, we'll use a kind of a real life example. The Minnesota Vikings had 4 turnovers last night. They had 3 turnovers in their first game. So what is their average number of turnovers per game? 3.5. How'd you do that? You added the 2 together and you divided by 2, correct? That's all we do with the midpoint formula as well. We take the x values and we add them together, x sub 1 plus x sub 2, and we divide by 2. That's the middle for our x value of our midpoint. And then our y value, y sub 1 plus y sub 2 divided by 2, that is going to be the midpoint for our y value. Okay? So let's try a couple examples where we use these distance and midpoint formulas. It first says to just give a general sketch on a coordinate plane. I'm going to go back 2 and up 4. I'm going to go over 3 and down 6. Now it is true that you don't have to sketch the graph in order to do this, but I'm going to do it so that we can check our answer, and I'll show you how that happens. Gave a little sketch to my graph, and now I'm going to find the distance. Square root of, what is x sub 2?
3.
So 3 minus the x sub 1 is negative 2. We square that. Y sub 2 is negative 6. And y sub 1 is 4. 3 minus negative 2 is 5. Squared is 25. And negative 6 minus 4 is negative 10. Squared is 100. Please make sure that these numbers you put there are always positive. When you square them, they'll always come out positive. You shouldn't have a negative anymore. We add them together, we get the square root of 125. If you could reduce the radical, please do. What's the perfect square that divides evenly into 125?
5. And 25 and 5.
Good. 25 times the root of 5, and I get 5 roots of 5. That is my distance. 5 roots of 5. Some people, when they go to the midpoint formula, they rely on the formula right away. We have the formula up there for you to see, but I think it's just easy to think conceptually about what we're doing. If you want to be able to find the midpoint, just take these two, add them up, and divide by 2. So 3 and negative 2, add to negative 1, or add to positive 1, divide by 2 is a half. Then you just go to your y values. 4 and negative 6 make negative 2, divide by 2, you get negative 1. Does 1/2 negative 1 look like the approximate midpoint of that segment? It does. So I've used that to kind of verify my midpoint result. I don't want to get that problem wrong on the test. So that's enough to be able to kind of help you get that idea. Do not draw a graph, but for letter B, please start by trying to find the distance and the midpoint. See if you can do the distance and the midpoint there. Try one on your own.
Yeah. So if you ever want to eat a toxic masculinity person, you shove your finger down Yes, we went over this. Did you know that?
I did not know that, but thank you for enlightening me.
Now you know.
I'll have to follow up later. Did you come up with a distance of 13? Yeah, distance should be 13. Okay. The midpoint, if you add the two together, you get -1. Divide by 2, you should have -1/2. And as far as the y value is concerned, -1 and 11 make 10. Divided by 2 is 5. That should be your midpoint. So distance midpoint problem on the test. Can we all get that one right? Okay. And we want to get those easy points there when they exist. So let's look to the application type problem. Okay. Seniors, just about all of you have taken the ACT. If you're looking to retake the ACT, your December or October is a great time to retake the ACT. Juniors, if you haven't taken it yet, you'll most likely take it in March. We'll prepare for that. But this is a really good ACT question that comes up. They will give you the picture of the triangle. We're going to draw the triangle right now. We're going to place points at 2, 2. And we're going to place it at 5, 6. So over 3, 4, 5. No, 3, 4, 5, 6. And then -3, 2. So back 3 and up 2. And I've got this triangle. Second, finish drawing that shape. As you draw it, there's 2 questions. The first question is, what triangle, what kind of triangle is it? And the second question is, what is the area of the triangle? So you have to try to extract some information from your geometry time. See if you can share with your partner, those next to you, what are the classifications for triangles according to length? Can you remember the classification of triangles according to length? Parents share, see if you can come up with them.
There's isosceles, scalene. I don't know which one's which though.
It's like all separate. Everything's
And then what was the other one I said? No, that's what This is isosceles. I just did the
equilateral.
Yeah, this is isosceles. It's obtuse isosceles.
So obtuse, acute, and right, those are classifications according to angles, right? So those are not classifications according to sides. Sides, you have scalene, which means that none of the sides are the same. You also have isosceles, which means 2 of the sides are the same. And then you have your equilateral, which means that all of the sides are the same. We would like to show which one this is. Any guess on which one this is?
Isosceles.
You think it's isosceles, so we would need to show them that 2 of the sides are the same. What's the length of this side right here?
5.
It is 5. How do you know that so quickly?
I counted it.
Yeah, he counted. He went from -3 over to +2. He says that that's a length of 5. So we know that this side is definitely longer, but what about this side right here? If in order to find that length, you would have to do what?
Use a distance formula, or you do triangle.
Yeah.
She said.
Yeah, why not just use a Pythagorean theorem and draw a shape? So instead of the distance formula, which I find to be bulky sometimes, don't you guys find the distance formula to be a little bit obnoxious? I'm just going to make a right triangle. I'll go over 3 and I'll go up 4. I went over 3 and up 4 to make a right triangle. Hey, I've got a triangle with sides 3 and 4. Anybody know what the hypotenuse is? 5. So you have memorized one of the Pythagorean triples. If you would try taking 3 squared plus 4 squared, notice that you get 9 plus 16, which is 25, so you get the side of 5. But you've maybe memorized that you have 3, 4, 5 makes a right triangle. Who else has memorized a Pythagorean triple other than 3, 4, 5?
6, 8, and 10.
Yes, a little bit cheating because it turns out that any multiple of any one is also. So you could do 1.5, 2, and 2.5. A multiple of any Pythagorean triple also works. But if you look at other integers, we have, say, 5, 12, and 13. That came from the problem right up above. You also have 8, 15, and 17. You have 7, 24, and 25. Now, you are not required to memorize these, but I will say second semester, this study of trigonometry is based 100% off of the Pythagorean theorem. And without a doubt, these numbers come up all of the time. And so it would be good to kind of keep those in your mind. So as you're working through this problem, you can see right away that that's 5 because it's a Pythagorean triple. Great, so that length's 5. I've got a scalene. Now let's do the easy part of the problem. Find the area. Talk to your peer. What's the area? Go. You can find the area of the triangle.
That's for red. So you get 4 times 5. Divided by 2. That's it. Dude, you're like a genius, man. So,
if you haven't said it yet, area should be 1/2 base times height. What is the length of the base of this black triangle? 5. Length of my base. The height would be the distance from the base to the highest point of the triangle. And you can see now that I've drawn this little nice right triangle off to the side, you can see that the distance is exactly 4. And so you have 5 times 4 is 20 times 1/2. The area is 10, 10, 10, 10. Okay. Good job. Flip it over. This is our new piece for today. And again, I'm going to reference a squared plus b squared is equal to c squared. Pythagorean theorem, very useful in many ways. One thing it does for us is it helps us to determine equations for circles. For example, the y is equal to mx plus b makes what shape? Starts with an L, rhymes with ein. Line, good. And then we have y equals x squared. That makes what shape? A parabola. So the equation that makes a circle actually looks like this. X squared plus y squared is equal to r squared. Hopefully it doesn't take you too much to be able to look at that equation and recognize that it is identical to the Pythagorean theorem. Its center is 0, 0. It has a radius of r. But suppose that the center is not 0, 0, that's shifted somewhere else, then the equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, as you write that down, I just want you to know it looks bulky. It's really not. And as we go through this lesson, this is the new piece that you're learning today that you haven't seen before. And you're going to find some nice, easy ways to get points on the test. And I'll show you right where that is. And we start with the first example. Example 5 says, write an equation for a circle with the following properties. It says that the center is -3, 2, and that the radius is 4. What that means is that the x value of the center is h. And the y value of the center is k. and the radius has a value of r. So that's h, that's k, and that's r. That's all that means. So if you go to your equation for your circle right up here, you're going to start by doing x minus h. So will it be an x plus 3 or an x minus 3? X plus 3. And then will it be y minus 2 or y plus 2? Y minus 2. And then do I write 4 or do I write 16? 16, I write the radius value squared. So notice as you look at this equation, this is an equation for a circle. It has the center at -3, +2, so it's opposite of what you think. And then this number on the end here indicates the radius. We take the square root of it to determine the radius. That's the form. Suppose that the center is 0, -5. Since we're not adding or subtracting anything, we could just write x squared. Plus, what's the next part? Y plus 5 quantity squared is equal to, now I have to square 1/2. Don't say 1. What's 1/2 squared?
1/4.
1/4. See if you do the last one on your own. A little trick there, so you can try that last one on your own. I hope you have x minus 3 quantity squared and y squared. The question is, what do you square what do you get if you square 3 roots of 2? If I take 3 roots of 2 times 3 roots of 2, notice I get 3 times 3 is 9, and the root 2 times the root 2 is 2. So you get a total of 18. 18 is the number that if you took the square root of it, you get 3 roots of 2. So if on the test I ask you to write an equation that has a center of that and a radius of that, could you do that? Good. Those are going to be easy points for you. Let's get even easier points. Now it says identify the center and the radius. Center and the radius. If that's my equation, what is my center?
3, -2.
3, -2. Again, it is opposite in value. What is the radius?
4.
Radius is 4. What's the center for letter B? 0, -3. And the radius? The root of 48. There is a perfect square that divides evenly into 48. So they may know what it is. Might be one of your ages. 16. So I get 4 roots of 3. It goes in 3 times. Okay? Son had one last night. One's the last. Oh, never mind. All right. Okay. These last examples. This one, I see this on the ACT just about every time I look at one, and it says, show that the following represent a circle by placing them in a standard form. Notice that this is not in the form of x minus h squared plus y minus k squared. And so what we have to do is we have to put it into that form. And it's not that bad. You have the skills. You're going to use this throughout the year. And this is one of those first examples we're going to apply it. We practiced it during the last unit. I separate the x's and I separate the y's. I put the 7 over there. And what's happening in this situation is that the standard form, it has what we call a completed square. We need to be able to complete the square in these situations. What number do you add to complete the square right here? 16. How'd you get that?
Divided by 2 squared.
Yep, 8 divided by 2 is 4, squared is 16. If I add it to one side, I add it to the other. Here I add what number? 36. Add it to one side, I add it to the other. And I get x minus 4 quantity squared plus y minus 6 quantity squared is 7 and 16 make 23 plus 36 is 59. Well, now it's in what we call standard form for a circle. So now that it's in that form, I know what the center is. I know what the radius is. Before I didn't. Now I know the center is 4, 6, and I know the radius is the root of 59. For the next one, notice that you just have x squared. That is a completed square. There's no other x's to go along with it. So we're good to go for the x. But then we have a y squared, we have a minus 6y, and we drop the 7 over. Right now, see if between you and your partner you can complete that square and identify both the center and the radius. Identify both the center and the radius. Go.
I've got to go with headband.
You go do that.
Percussion and stuff like that.
You're gonna rock.
Thank you.
I didn't know you were in band, bro.
Yeah.
I thought you don't quit.
I play the cool instrument though.
What instrument?
Drums.
That is very cool.
Boom. Love the drum group.
You get it?
Grant, did you get it?
No, I was still writing it down here. It's alright. Almost there.
It's alright. We'll finish it for you.
I should get x squared plus y minus 3 squared is 16. Your center should be 0, 3, and your radius should be 4.
Did I get that? Oh, I got it.
What'd you
Now I
get?
got it. I got 0,
Oh,
negative
I
3 on
didn't-
accident.
I didn't add
Because
nine.
I forgot to reverse the.
That's all right.
I did not get it. Oh.
Okay, last example. Find an equation for a circle. Center is negative 1, 2. Passes through this point. Talk to your peer. What do you need to do to be able to accomplish this problem? Come up with an idea. Anything. A little bit different what we've done. Write an equation. Passes through that point. Center is there. Talk to your peer. What would you do? Go. Come up with an idea. Come up with something.
What possible like 7, negative 13.
That makes it quick.
So you could be like, oh,
Because then.
what is the distance from here to here? That's the
I think
radius.
it's easy.
Wait, do we gotta solve right now or just talk about how to solve?
Talk about it. Give me 10 more seconds.
Alright, so, and then you get the radius, and then you got the center. And then you plug in the radius and the center there. And then you get the answer.
7 is the radius of negative 13. That's like
Me too, man.
so. If the center's here
Because you do this.
and
Yes, I felt like this is that's like the radius.
it's gonna be about like that.
Okay, x plus 1 squared, y minus 2 squared equals, okay? And I heard you guys talk about it. How are you going to come up with a radius?
You're gonna use a distance formula between negative 1, 2 and 7, negative 13.
Very good. If the center is negative 1, 2, and it passes through 7, negative 13, that means that this circle goes all the way around that guy. Okay, really bad circle. But by definition, the radius is the distance from the center to that point. So you could just use the distance formula in this situation, and you should be able to locate exactly what the radius is. So let's knock out that distance formula. We have the square root of, we do x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. 7 minus negative 1 is 8. Squared is 64. Negative 13 minus 2 is negative 15. Anybody know what 15 squared is?
225.
225.
Alex did that.
64 and 225 make 289. What is the square root of 289?
It's definitely a number. I've heard it before.
It is 17.
That's the one.
So instead of this r squared, what number do I put there?
17.
17 squared. So 289 is the number that goes there, and that's the mistake that often people make. Flip to your homework. You have about 8 minutes. I'm going to tell you that the first parts of your homework don't take that long. You might be able to finish a decent amount of it. I just want you to know that you are asked to sketch the graph of a circle in some situations. Suppose that your circle has a center of -1, 3 with a radius of 4. I just want to show you when I say graph the circle how quickly this can go. I go back 1 and up 3 and I put a dot. And then I just go 4 units in each direction. Draw the circle. That's all we're talking about. Okay? Plot the center, move 4 units in each direction, try to draw the circle. And then make fun of each other by how ugly your circles look. There's no way they can look as bad as
Yours
mine.
has gotta be hideous.
I'd say that.